Imagine standing in a pitch-black room. To understand your surroundings, you throw a projectile into the void. If it bounces back instantly, the barrier is close. If it takes longer, the room has depth. Passive reconnaissance is an observational process, like analyzing a target's discarded data from a distance. Active reconnaissance requires direct interaction. It is the process of probing a network to see how it reacts. In a digital environment, this functions as sonar. Instead of sound waves, we transmit specific network packets, discrete units of data routed between a source and a destination, and measure the echo of the response. Most networks are configured to be functionally invisible to unauthorized users. To map the architecture of a target, an attacker must provoke the system into revealing its own presence. Consider a high-end corporate perimeter. It is typically shielded by a modern firewall, a security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. Attackers rarely attempt to breach these hardened perimeters using brute force. Direct assaults are loud, easily detected, and generally ineffective against enterprise-grade hardware. The strategy shifts to a deterministic four-step pipeline. It is a systematic process of elimination designed to find a single point of failure or a minor misconfiguration. This sequence is strictly cumulative. The data extracted in one phase serves as the mandatory input parameter for the tool used in the next. Active reconnaissance is the mathematical transition from total ignorance to a precise, documented entry point. At the start of an engagement, an attacker only has a broad range of target IP addresses. At this stage, it is unknown which of these addresses are actually assigned to an active, powered-on machine. The methodology begins with Step 1, the pulse, operationally known as ping sweeping. Using Nmap, the attacker broadcasts a wave of data pulses across thousands of IPs, utilizing protocols like ICMP to confirm if a host is reachable. The scanner logs the responses, discarding inactive nodes and isolating only the systems that are online. Confirming a machine is live is only the baseline. It proves a target exists, but it does not yet provide a way to interact with its internal services. This leads to Step 2, port scanning. Every IP address contains 65,535 logical ports. Each port is a communication endpoint for a specific service, such as a web server or an encrypted login shell. The attacker uses Nmap to systematically query these ports, checking which accept a connection and which are blocked. The scanner ignores closed ports and identifies the single one returning an open state, confirming a service is actively listening. These first two steps reduce a massive, blind network range down to a single listening service on a specific target machine. Finding an open port is not a breach. To advance, an attacker must identify the exact software responding on the other side of that port. This requires Step 3, service detection, also known as fingerprinting. Every open port is managed by software, such as an Apache web server or a MySQL database. Each of these applications has unique behaviors and communication patterns. Nmap sends targeted probes to the port, forcing the application to return a banner identifying the software. The tool extracts the exact name and version number, such as Apache version 2.4, which is the critical output of this phase. Obtaining the version number is mandatory. Without knowing the exact version of the software, an attacker cannot know which specific vulnerabilities are present. Service detection transforms an anonymous connection into a defined, quantifiable piece of software with a documented security history. Once the software is identified, the methodology shifts from discovering the network to identifying its weaknesses. This is Step 4, the inspection, operationally known as vulnerability probing. The attacker utilizes specialized tools like Nikto, a web scanner, or SearchSploit, an exploit database. These act as targeted search engines, cross-referencing against known security flaws. The identified software string is fed directly into these tools, comparing the version number against a massive database of CVEs, common vulnerabilities and exposures. A positive CVE match reveals the specific structural flaws, the exact exploitable code paths that exist within that specific version of the software. At this point, no attack has occurred. The attacker is simply mapping the weakness, determining if a known exploit can be used to gain unauthorized access. By following this methodology, the attacker has built a blueprint for a breach based entirely on the network's own automated responses. To see how this applies in practice, we can track the 4-step framework against a high-security enterprise target. The target is a large corporation protected by a properly configured perimeter firewall designed to block all standard attack vectors. The attacker initiates an Nmap stealth scan. They begin with Step 1 and 2, mapping the active IP addresses and scanning for open ports across the entire corporate range. The primary firewall blocks the scans. However, the attacker discovers a single anomaly. Port 8080 is open on a single IP address that sits outside the main security rules. Moving to Step 3, the attacker ignores the secure production environment and runs service detection against this port. The scan reveals a deprecated development server left running by an admin, hosting an outdated file-sharing app. This vulnerability was not a failure of the firewall's code, it was a failure of administrative oversight. In Step 4, the attacker uses Nikto to cross-reference this legacy software against known vulnerabilities. The scanning tool returns a successful match. This specific version of the software has a known flaw that allows an external user to upload and execute a malicious file. The corporation has invested millions of dollars into its state-of-the-art perimeter defenses to ensure that the core network remains completely impenetrable. But the attacker never had to interact with those defenses. They used active reconnaissance to find the one path that was left open by mistake. Active reconnaissance proves that enterprise security is only as strong as its most neglected link. It provides the attacker with a documented path to full system access without ever engaging the primary firewall.